Hello, this is Kirk Whittig. I will be discussing visualizing hypothesis testing today. Before we jump into this, let's go over the objectives. First, we'll want to identify how to make the question. Then go over how to identify the null and alternative hypothesis. We'll follow that by how to pose a question from the data using an independent variable and a dependent one, setting the parameters of the study, or what argument would we like to make, and verify using the supportive data and statistics. And then we can either do this in numerical form or we can use words. Whatever way you would like to do for setting up your null or alternative hypothesis is up to you. So now we'll look at some simple instructions for deriving and testing a question. First, we need to ensure you make a testable statement with at least two minimum variables. Remember, variables are anything that varies and can be things like units, so height in inches and feet, or even miles per gallon. They can also include things like motivations. Remember, you don't need to believe in your null hypothesis. After you come up with that, then choose a value or point of divide so that a null and alternative hypothesis can be discerned. Finally, use an alternative hypothesis, but remember you must first know the null to state this one and simply offer a predicted outcome change for the alternative compared to that of the null. Let's first look at visualization, test for a mean. Here we can see that we have a symmetric bell curve, which means the outcome for the study will either be left or right of center, which we will know once we determine the deviation of the data. So right here we have the mean showing we have 0 defective widgets with a probability of 40%. Therefore, the research question is, on average, are the widgets from Acme Widget Company defect-free? Yes, we have a 60% on average probability that there will be 0 defective widgets. Therefore, the null hypothesis, defective widgets, equals the mean. We can have an alternative hypothesis that says defective widgets do not equal the mean, and that this was basically a one-time occasion off these hundreds. So that's what we can test to see if this continues after the 100 and going up to 200, 300, for instance. Comparing two groups. So in this one, we have two different bell curves where each one has its own mean, and then there's a mean of the two right there. We have the number of home runs and the fraction of team that are home run hitters on the majors and the minors. So the research question is, does the average major league team have more home run hitters than its corresponding minor league team? By looking at this, we would say yes. So again, we would want to set up an alternative hypothesis that can be in conjunction with the data we are seeing. So the null would be something that we can disprove or be an equal type of a statement. So we say the majors hit an equal amount of home runs to that of the minors. The alternative hypothesis would be that the majors hit more home runs than the minors. In this one, looking at the efficiency comparison, we have blue data showing a large standard deviation, and we have red data that shows very little standard deviation on its bell curve. So with that, we could, in looking at our research question, the efficiency curves of the red and blue teams were recorded. Do the teams have equal mean efficiencies? So the null hypothesis could be that the number of customers served is independent of the number of servers. The alternative hypothesis in regards to this question could be the number of servers affects the number of people served per hour. Visualization number 4, the correlation test. Since it's determined that there is a significant correlation per the guidelines of this slide, we assume there is a significant relationship. So our question, therefore, must assume that significance. And the significance we're looking at is that weight is correlated to miles per gallon. That's why this question says, how much does an extra 1,000 pounds of truck weight affect miles per gallon, thereby assuming the significance. The null hypothesis could be then, an extra 1,000 pounds of truck weight will not affect miles per gallon, so that's kind of a neutral statement, or an equals. The alternative hypothesis, on the other hand, could read, an extra 1,000 pounds will result in lower gas mileage. So there's the change. Equal, less than. So some key takeaways. Creating hypothesis tests. You can apply numbers or words for your hypothesis questions, as I hopefully showed. For sake of ease, your null hypothesis can state equity between the data sets. The alternative hypothesis should state a change and not have that equal between the variables. Using visualizations. Think of a visualization or graph, in this case, as an infographic. What is it trying to tell you? I really liked this bell curve because you can think of it in terms of people. Here's where your average performers will be. Here's where your high performers, so to the positive side of the bell graph, will be. And these are your underperformers, and there's a lot less. So that's a real good visualization of what data is trying to claim under that bell graph. Also, as noted in Hess's video, he says if you can visualize it, you can hypothesize about it. I think that's a really good way of looking at graphs. Thank you for watching. If you have any questions, please let me know. Thank you. Finally, I just wanted to point out the references to help make this presentation possible.